Now, what happens when you get a number of variables, more than one? Look at this guy. I got an x squared here. I got a y squared here. Oh my goodness, what do? Well, actually, don't treat this any different than a standard PSA question. And if you look at this one, we try to factor out a 2. You can't. So this, in fact, is still going to be a PSA 2. There's no real challenge to this. You know this times this is going to give you 4. You know your middle term is going to be 5. But let me show you something really cool. Because that's going to be a positive 4, that's going to have to be a 1 and 4, a negative 1 and negative 4. Okay? Because negative 1 and negative 4 is going to add up to our negative 5. But check this out. How are we going to decompose this? How are we going to write this guy like this? Well, it shows you right there. Write it as an xy. Check this out. This is going to be 2x squared minus 4xy minus xy plus 2y squared. That's how you do it. Notice how you haven't changed this guy again. It's still an xy, and so are these two things. They're both xy's. They both add up to minus 5xy. So is there anything different that you have to do? Actually, no. Still group factor this. Okay? Still take out, in this case, you're taking out a 2x. And by taking out a 2x, you're left with an x here and a minus 2, and you took this x out. Look at that. You're left with an x minus 2y. And in this case, notice the signs are wrong, but GCF tells you can take out a negative y. Signs are wrong, so you always take out a negative. Okay? Y is a common term to both of them, and look what happens. Look what you're left with. X minus 2y. And look how these two factors, again, are the same. That's so awesome. I love it. So watch this. There's your x minus 2y that you took out. That's gone. That's gone, leaving you a 2x minus y. There's your factorization of, oh, the guy that we can't see way up there. But I know what you're asking yourself. You're probably saying, what if I FOIL? Can I get this actual term with the xy and the y squared back in there? Well, you know what? Let me show you. You will, in fact, get the original question. Here we go. Watch. FOIL it. There's your 2x squared. FOIL. There's your minus xy. There is your minus 4xy. And there becomes your positive 2y squared. And if you keep that going and combine like terms, there's your 2x squared, there's your minus 5xy, there's your plus 2y squared, which was your original problem. Pretty nice, isn't it? So stick to your guns. Don't freak out just because there's two variables, okay? So let's go and do this one over here the same way. Notice there's a 2 up front. So can you factor out a 2? No. So it becomes a PSA 2. Here we go. And you're going to decompose this. 2 times minus 15 is minus 30. There's a minus 7. Two numbers to give you minus 30 are minus 10 and 3. So minus 10 plus 3. Replace that middle term. Decompose the middle term. Here we go. 2n squared. The middle term has to be minus 10 nm and a plus 3 nm and a minus 15m squared. Isn't that cool? Keep on going. All right, I need a little more room here. Here we go. Group factor, just like before. Check it out. Oops, should have been around the square. There we go. Take out a 2n, leaving you with an n minus 5m. Out of here, you can take out a 3 and an m. Okay, take out a positive 3m, leaving you with an n minus 5m. And there's your common ones. There you go. N minus 5m. That's gone. That's gone. 2n plus 3m. And there's your factorization of that. So when you get two variables, don't freak out. The decomposition method using PSA 2 is going to help you out all the way through it.